Hello, everyone. Welcome to the Data Flowcast. I'm your host, Mark Lamberti, and I'm super excited because today I'm joined by Jonathan Rayner, staff engineer at Apollo GraphQL, previously data platform engineer at Monzo Bank. So, how are you doing, Jonathan?
Hey, well, thank you very much for having me. It's really great to be here. Yeah, doing well, doing well. Lots of it's always this kind of period in the kind of wind down to Christmas when you suddenly realize everything you have to get done before you wind down, and so we're in that kind of crazy period at the moment. But that's life sometimes, isn't it?
Yeah, I feel you. I feel you. But I actually haven't prepared anything yet, so maybe I should. All right. All right, so let's dive in. For today's podcast, we will discuss about DAG consistency issues, UI scaling challenges. I mean, honestly, this one for me is really interesting.
Mm,
Because when we talk about scaling issues, we always tend to think about resources like memory and CPU, but
mhm,
actually, how do you use the UI when you have thousands of tasks? That is
mhm,
something that you need to take into consideration. Then how to monitor Airflow at scale and some practitioner lessons that you learned through your
mhm.
journey with Airflow at scale. So maybe we could start with some background, like what did you do at Monzo Bank as a data platform engineer?
Yeah, cool. So essentially, I was part of the data platform engineering team at Monzo, and so the idea was we were responsible for the ingestion of data from all of our microservices and from the phone apps that we had deployed, the processing of that into raw events, and then also the Airflow instance that ran the models created by our data analysts and that kind of thing. And then also we sort of had a tangential responsibility for our Looker instance as well, which is running all of our kind of BI visualizations and that kind of thing. So it was very much the pipeline end to end, but we were very clear that we were trying to be responsible for giving our data analysts a platform to run models on, rather than being responsible for the content of those models specifically. So that was very much kind of where we were situated. So Airflow for us very much sat kind of right in the middle of that. So we had kind of raw tables at one end, and then our analysts would create DBT models that would transform those raw events into various derived data products. And then Airflow was really the workhorse that was scheduling all of the compute we needed. So we very much used Airflow as a scheduling tool. So we weren't running big compute intensive computation inside of it, but we were very
Mhm.
much using it to schedule computation within BigQuery mostly. We had a couple of like custom Python workloads that we ran that did actually run kind of inside of Airflow itself in some sense. But most of it was outsourced to BigQuery and so we were using it as a scheduling mechanism essentially for those things.
Okay, that's interesting. I actually like. Did you try to run things within Airflow, or did you just wanted to use it as a scheduler?
So it was quite an interesting kind of philosophical question almost that we
Yeah,
tried to answer. It's kind of
exactly.
like that was I very much I because when I was at the Airflow Summit in 2023, I remember there being this kind of interesting point where this came up in one of the panels, and someone was like, "Oh, maybe it should just be a compute platform. Maybe it should
Yeah.
be just a scheduling platform." It's interesting. I think a lot of that came from the history of where the data warehouse at Monzo came from originally. So it started out as in the kind of pre-DBT days as like hand stitched together SQL that existed. And so in most cases, because the data models were all expressed as SQL models, it made sense for them to just be things that were run in BigQuery. There wasn't a lot of heavy duty Python processing or any of the kind of things you find in some other data pipelines. So for us, that
Mhm.
kind of made sense because of the kind of things we were processing. But I can see in a world where if your lingua franca is Python, if you're running machine learning models, whatever else, then I can kind of see why you might want to schedule that within Airflow itself. But I think it's
Mhm.
interesting that Airflow allows you to take both views and isn't that opinionated on the way you want to go with it. So for us, it made sense for it to be a schedule, for it to be just a scheduler, but that mostly is a sort of historical thing about where our models lived and the kind of models that our analysts wanted to build.
That's a very good point. That's a very great point. I actually, at the beginning, I was extremely like I was very opinionated on the fact that you
Mm,
should not use Airflow as a way to run your task, but really use it as an orchestrator. I
mm,
I think I changed my opinion a little bit. I mean, as long as you know what you are doing, to your
mm,
point, like Airflow has this flexibility to, offer you both ways. Ultimately, it's up to you to know what should be the best
mm.
for you.
I think one of the problems that starts to arise is you then start having to use Airflow to consider things like, so in our case, we are running a top Kubernetes, so we're running our own kind of installation of it. if you then start to use it as use it to run compute directly within Airflow, you then have to start considering things like, oh, do I need my analyst to understand that, this particular task needs resources for some reason, this particular one needs GPUs. So you just end up with a much more complicated, or you can end up with a much more complicated kind of abstraction at the top level. But it also depends upon, it depends upon so many dynamics, including things like your analyst level of
Right.
experience. Like some of them some of them understand all this stuff, and other people are just kind of like, I wrote some Python, just run it for me, I don't care. Like it's kind of on a continuum somewhere, right?
Yeah, that's true. That's very true. Great. So I guess like, I mean, you said a little bit about that, but what does your team use Airflow for? When you were at
Mm.
Monzo Bank, like maybe if you have one use case in mind, because I imagine that you were using Airflow for many different use cases, but have if you have one in mind,
Yeah.
and
So,
with and with some numbers as well, just to
oh,
see.
okay. Yeah, no, totally. Yeah, yeah. So, so, so the big use case that we had for Airflow was our nightly DAG that we ran. So this is a DAG that runs every 24 hours. It kicks off at 1 in the morning. And the idea, or the ideal, was that it would be finished processing the sort of 8 or 9 most significant models that we had by 9 o'clock in the morning, so that it was ready for analysts to come in and do their work at night. That was the idea. So these were models like, things that banks care a lot about, transactions, accounts,
Mm.
that kind of stuff. So these are big models themselves, but also we're talking about a DAG with 8,000 or so tasks in it. It's probably more now. It was about 8,000 when I left. It's probably more now. But so you're talking about something quite big, essentially to work. So that was kind of one use case, was just doing the number crunching of working out like, what do all our accounts look like? What balances do people have, all that kind of stuff. But then there are also other use cases in there. So doing things like creating feature sets for our machine learning classifiers was another thing
Mm.
we used it for. And also even things like credit scoring, like you're building probabilistic scoring models, and then, kind of using that. So even though everything was mediated around these big SQL models, what they were actually used and pushed into in many cases was quite different. The big and to be honest, oftentimes the biggest consumer of that was our Looker BI instance, essentially. So
Okay.
we're trying to create models that you can therefore give insight to non-technical stakeholders. So a lot of our biggest dashboards were being served directly to leadership and that kind of thing. So there were some models, particularly around things like liquidity, that are, really important that you get right, because obviously if you're a bank and you're not solvent, that's not particularly great. So, there's a sort of, there were kind of interesting constraints on certain models around correctness and that kind of thing. I guess the other big constraint, or the other big use case for us, was regulatory reporting. So it's kind of a big thing, again, with being a bank, a big thing you've got to get right. So a lot of the regulators have very particular formats that they want data in, and very particular kinds of data. And they also have very specific restrictions about, if they come in and say you're being audited on a specific day, you have to have the data to them by a specific time on that day. So it's a very, very specific, format. And it has to be, because that's what,
Yeah.
you've got to be regulated in these industries. That makes sense. But so that was another big deal for us, with making sure that when our pipelines were running, we were getting the right data. So if an audit were to happen at very short notice, it would not be a problem to compute the data required. So those are kind of a couple of the use cases that we kind of had in mind for it.
This is awesome. So I guess like it is safe to say that Airflow was pretty critical for you.
Def- Definitely, yeah, definitely. It was something, especially in the world of regulatory reporting, where the penalties for getting that wrong were very, very high. It was the kind of thing where if you were being paged about it at 6 in the morning or even earlier,
Mm.
you weren't like, I'm just going to put my phone down. That's fine. No, no, no. You were on your laptop at whatever time in the morning to get it fixed. It was
Uh,
very, very important stuff.
so I guess like, when you are running Airflow at that scale, I mean, you mentioned that you had to run thousands of tasks.
Mm.
And by the way, you said models. Are you talking about DBT models or just like SQL
Yeah, so
regular?
yeah, so this is important. This is a bit of an important nuance to draw out, because there was a bit of a difference here. So the way that it worked for us was that our analysts were working on DBT models in general
Okay.
terms. As I said, there were some like bizarrely specific Python models that some people built, but
Mhm.
99% of the time we were working with these SQL models. But what we did, we, I mean, obviously I know that Astronomer has the Cosmos product, which is a kind of a way of mapping from DBT tasks
Yeah.
into Airflow tasks. And so we kind of like pre-invented a much worse version of that, like back in the past. So so you guys have done it better than us, but we kind of pre-invented our own version of it. So the idea was that in CI, we would take all of the model definitions, generate all of the SQL for them, and then that's what Airflow would actually end up running. And you'd also create from that a definition of the DAG that Airflow could consume. So that's the kind of the mapping bit that's interesting. So 99% of the time when I say task and model, they're kind of interchangeable, but there is that weird little subtlety about the Python models. So it's not quite as precise as I might like it to be.
Okay. Okay. Yeah. Okay. Thank you for the distinction. So I guess like just to cycle back on the number of tasks that you were running, did you? I mean, I guess, did you have any issues like running so many tasks? Like
Yeah. So there was a whole host of issues that threw up, as you can imagine. I mean, so as we've kind of already alluded to in the introduction, like the perspective of certain components of Airflow not scaling particularly well for that size of DAG in particular. I mean, this is also to say that like we weren't just running a one single DAG. There were multiple DAGs, but the
okay.
nightly one being the largest was the biggest problem that we had. And so there was that kind of technical thing, but there was also kind of more conceptual problem in the sense that so much of monitoring Airflow is built around the idea that you can use the UI to observe what's going on in your DAG, and also that the reasoning element can be done by a human by inspection. There's kind of this is never like written down in any of the Airflow documentation, but it is in a kind of assumption that gets made as you go along. So when we started having issues around DAGs being in inconsistent states, that was hard to track down initially because so much of that isn't a problem when your DAG is only, say, 20 things in size. You can easily see if that's consistent or not. But for us, it was much harder to track that kind of thing down. And so we had to start thinking about, well, how do we convert some of these kind of human insights into metrics rather than thinking about them
Mhm.
from a kind of insight level? So yeah, there were kind of multiple different issues that operating at that kind of a scale started to give us.
And I guess like it is interesting because you just mentioned consistency. Can you
Mm.
define what do you mean by that consistency?
Yeah, so if we think about that consistency comes from the idea of task consistency. So that's a kind of this place to start. So
Mhm.
obviously in the FO documentation, we talk about tasks, and obviously we have the nice state diagram that says, tasks move from this state to this state, and that's how they do it, and that's what it means, and all that kind of
Mhm.
stuff. So obviously for an individual task to be in a particular state, all of its upstreams should be also in a specific state. So for example, if it should be impossible for a task to be in a successful state if a task upstream of it is in a waiting state, because obviously it
Yeah.
doesn't make any sense. So the one that was interesting to us was, well, if a task is in an upstream failed state, then it must have an upstream that has failed. That's,
Mhm.
again, by definition is pretty obvious. And
Yeah.
so what we meant by DAG consistency is to say that every task in the DAG is in a consistent state, by which we mean that the state the task is in an accurate reflection of the upstreams that it has and the downstreams,
Mhm.
but most of the upstreams. And so the way that manifested for us is that what we would start to find is we would occasionally end up with the throughput in the DAG going down to zero. So nothing was executing because we had tasks that were in an upstream failed state, but nothing upstream had actually failed. And so
Okay.
this was really hard to detect because from the DAG runs point of view, everything is fine. Like it's still executing. Nothing is wrong in some sense.
Mhm.
But
Mhm.
from our point of view, throughput's gone down to zero. Nothing is executing, and the DAG run's effectively stuck. Like it can't do anything because it can't resolve this inconsistency. Because the DAG shouldn't be allowed to get into that state, and yet seemingly it does. So that's those are the kind of problems that we started encountering.
Wow. Okay. That is very interesting. So I guess like I mean I have so many questions. The first thing is the first question that I have to you is how did you find out that you were having those issues?
Mm.
Because to your point, like when you have like thousands of tasks, and I mean I guess like maybe looking at the UI might not be
Yeah,
easy, right?
yeah.
I mean,
Yeah, that was definitely the case. So a lot of it, like, so there's kind of a flippant answer to this, and there's a more serious one. The flippant answer is we kept being pulled into incidents where this kept being a
okay.
problem because especially because we had a kind of implicit time limit where it's like if this stuff's done after 9 o'clock, that's a real issue. As soon as we started getting to the point where you'd get to say like 10:30, 11, and nothing had happened for a significant period of time, that was where, then you'd start to then kind of inspect the DAG yourself and be like, oh, hold on a minute, this doesn't really make any sense. But you're very much applying kind of human intuition on top of the data
Mm.
model that Airflow gives you, essentially. So the way that we started to effectively see it was we get pulled into these incidents, and then in these incidents, you'd go and start to look at the set of failed tasks, and then you'd start to go look at their upstreams and compare that to then what Airflow is telling you as an upstream failed state. And then the sets would be disjoint, and you'd be like, well, hold on, that doesn't make any sense. How can it be how can it be an upstream failed state if it's not upstream of a failed thing? That doesn't make any
Yeah.
sense at all. And so for a while we dealt with it manually. Basically, we would find the inconsistent ones and clear the task with downstreams, and that would start to kind of resolve the problem because that was relatively easy to do, and it doesn't require a huge amount of kind of intelligence. But
Mm.
this happened quite a lot. There was a point where it was happening, like I think it was happening nearly every day that we ran the DAG, and so this was getting to be just ridiculous. It just got to being ridiculous after a while. So
Okay.
we then started to look at it and think, well, hold on a minute, like, is there a way we could automate any of this? Could we start to build something that would actually solve this for us? Because I mean, and also I think to probably address at this point, like what we were seeing, as far as we could tell, is some problem with the way that Airflow does task state updates. And so we think, although this isn't based on a huge amount of data because it was very hard to capture exactly what was going on, but we were pretty sure that what was happening was when Airflow was trying to clear a lot of tasks at the same time. But so the order of events would be something like a task in the DAG failed quite early on, and it's got a lot of downstreams.
Mhm.
So when Airflow is trying to set the state of all of those downstreams to cleared, especially if one of those downstreams is also downstream of something else in that same
Mhm.
set, you can end up in a sort of lost update problem where instead of it being upstream failed, cleared, it ends up being upstream failed, cleared, upstream failed. And obviously that's incorrect. Obviously that's an issue with Airflow, but because of the fact that it was very, very hard to get the bug to reproduce in any sensible way. We couldn't create a minimal example. It was the proposition of going to the Airflow community and being like, hey, we
Mm.
have this really ill-defined thing that we're not really sure if it's a problem or not. Like, it was a very kind of hard sell. So we were like, okay, let's see what we can do in the shorter term to fix this. And so we built something that could do this consistency scanning for us, because all we were doing is graph algorithms. And this is like, computer science 101. This
Yeah.
is, back in the day, easy stuff. So we built a service that could do that, and initially started it in just reporting mode. So just tell us if there's a consistency issue. And then we moved
Okay.
on to actually compute a solution and run the solution through properly. So those were kind of the steps were initially do it manually a couple of times, and then go on from there. How can we build in a kind of automated process to make this more consistent? Obviously, the real solution would be let's go fix this properly in Airflow, but it was very much a case of we need a solution to this quickly, and also it was a
Yeah.
case of and also at the time there were issues, not anymore fortunately, but there were issues with us being stuck on older versions of Airflow for lots of other unrelated reasons. So it was like, even if we do get a fix in the upstream, we can't even necessarily take it at this point because of these other issues. So it was very much a kind of like, how do we build something that can solve this problem for us, where we don't have to make big changes to Airflow at the current time? But that was kind of the route we took.
So I guess like were you actually able to ultimately fix that issue, or you had to?
So we built a solution that worked, and
Mhm.
in my last couple of months, I think it saved us about 11 or 12 incidents, I think, over the course of time. So we
Oh,
definitely built
okay.
something that worked, and it could resolve the problem. We we had hoped. So one of the reasons we thought we might have been triggering this was because in the version of Airflow we were stuck on, which I think was 2.3.4 time,
Okay.
the clear task API endpoint didn't have a with downstreams option. It was added a bit later in.
Mm.
So the general pattern at Monzo was that you would build a service that ran in our cluster that fronted your API, so that you didn't have to keep kind of connected to the API, which is totally fine. So in our service, we built a bit of extra intelligence that would kind of pretend the clear with downstreams option existed, but actually that was all implemented in the service itself. So we hoped that when we upgraded and we got the clear with downstreams, that would start to solve this problem to some extent. Because
Mhm.
if you could make the task clearing process atomic, so you basically say, okay, all these tasks clear at the same time, and the state is everything after the fact, rather than this kind of piecemeal process,
Mm.
we thought that would help. However, we upgraded to latest Airflow 2, and we still saw this problem occurring. So there's clearly something else. As I say, I've since left, but whether they've upgraded to Airflow 3 since then, I don't yet know. So it'll be interesting to see if that solves the issue as well. But the problem is, it's also hard to know exactly where the problem might be, because it may well be really deep down in the database drivers level. So it might even be not an Airflow issue at all. Be something to do with the
Yeah.
database libraries. So it's it's something that it's very likely that something else will fix over the course of time. But obviously you can't. But it's
Yeah.
hard, because it's hard to kind of identify exactly the root cause. It's very hard to kind of fix in that specific way.
Yeah, yeah. I imagine like, I mean, I remember that when I was a data engineer at a bank in France. And I mean, I know what it is when you have this issue that you can't reproduce for some reason.
Mm,
And it's just a nightmare because
yeah,
like, I mean, how
it's
do you know it? Yeah, I mean, how do you know exactly the root cause if you can't reproduce that error and it
yeah,
happens like time to
and
time?
exactly. And exactly when it's so public as well, because that was our other kind of big thing, was like all of these people, especially kind of big execs, are looking at these data models and they're being like, why aren't they refreshing? So, and it ultimately comes down,
Mm.
when it comes down to, or it feels like it comes down to your team. It's very difficult to be like, well, we sort of know what the problem is, but we kind of also don't. Like, it's a very, very frustrating thing to not be able to give them an answer of like, yes, we know, we're doing our work on it. So even on a sociological level, like it's kind of so much more frustrating than just a technical problem.
Yeah, I mean, I imagine that many engineers listening to us right now will feel you.
Yes, I'm sure. Yeah, I'm sure there will be a huge amount of sympathy. I'm sure.
Um, so I guess like you mentioned that you built that external system to monitor
Yeah.
that consistency. Maybe can you just maybe explain us a little bit more what it is, like what it actually
Yeah, of course.
build?
Yeah. Yeah. So as I said before, because we effectively built the DAG in CI before, that made it a lot
Mhm.
easier, because the structure of the DAG, so the non-dynamic part, was very easy. We could get that. We actually stored it in BigQuery as a kind of big list of nodes and arcs. So that's very easy. So what we would then do is we would take that static structure, and then you would make a few requests to the FO API to ask it for various different things. So you basically say, what tasks do you think have failed? So that's one set. And then what tasks do you think are in upstream failed? And that's the second set. And then essentially you would take each of those upstream failed tasks and work back through the DAG and
Mm.
basically say, if I start from here, can I eventually find something that's failed upstream before I hit the root? And work through that for each of those upstreams. And if you find one where you can't, then flag the DAG as inconsistent. I mean, in reality, you check all of them and then you give it a whole list rather than failing early, but
Mm.
that's the idea. So you're basically taking the kind of static information from that we'd already recorded, and then using Airflow to kind of layer the dynamic information on top of that, and that's how you ultimately make the decision. Obviously, you could pull the whole DAG structure out of Airflow immediately. You could do it all through the Airflow API, but for various reasons, including the fact that some of our tasks were very big because they had these big JSON payloads attached to them for
Yeah.
reasons that are very complicated. But basically, it was so that was putting an awful lot of strain on the API itself. So we decided not to go down that route and use this kind of pre-done version effectively. But yeah, but the important thing was going to Airflow for the dynamic information, because obviously information you can only get from Airflow. And then once you've done that and you've worked out where the inconsistency lies, you essentially then you perform a slightly different process where you work downwards and work out what's the minimal number of tasks I need to clear in order to get all of this stuff cleared. Because obviously, kind of if you can get to something quite high up a DAG, it's got a lot of downstreams, the likelihood is you're going to have to issue fewer API calls overall in order to do that. So
Mm.
that was the kind of system that we ended up with. And as I say, the first version of that, it basically just reported into Slack and just said, hey, the DAG's in an inconsistent state, clear these tasks in this order and you'll be fine. And then there was a kind of unattended mode, which we turned it into later on, which basically said, okay, that list I told you about, I'm going to now do that in this order. And that would just work unattended. So because the other thing that made this kind of more entertaining was that, or entertaining is the wrong word, but kind of frustrating is probably the better way of describing it, is that this stuff would always happen at like 4 a.m. or some kind of like,
Of course.
really on. Yeah, because Murphy's law, right? If it's going to happen, it's
Yeah,
going to
right.
happen at the worst possible time. So it was the kind of thing where like any solution basically had to be automated because otherwise, you'd end up with these huge problems. So yeah, so it started off as a kind of as just a reporting mechanism, and then moved on to actually then trying to fix the problem from there. So that was the sort of rough kind of order of operations it took.
This is super smart. I mean, obviously, like I'm a huge fan of automating everything we can,
Mm.
because ultimately, that's the way to avoid becoming crazy.
Yeah.
Especially when you have your
Yes,
especially
definitely.
when you have like errors at 4 a.m. Great. So I guess like moving on to again, like actually coming back to some scaling issues.
Mhm,
So we talked about the DAG consistency, but obviously the UI is also very important. And again, we don't think
mhm,
about the UI that much. We always think about, hey, uh, you know, am I gonna am I gonna have enough like CPUs and memory
mhm,
to scale Airflow? Do I have the budget for that? And so on, right? But we don't
mhm.
think about truly like the UI. Like, am I gonna be able to use the UI with like the same way when I have two tasks than when I have thousands of tasks? So to your point, like, I mean, actually, based on your experience, were you still able to use the UI? Like, go to the graph
Mm.
view and then look at the tasks? Or did you have to build something on top of it? Or like, I guess, like, what was your experience with it?
Yeah. So the UI, for the most part, was pretty reasonable up to about 1,000 tasks or so. That was, I think, where the kind of limit started to show. So our big problems were things like the some of them were really, really minor things, like the fact that the default number of runs when you click on a DAG is 20 is a real pain for some when you have 8,000 tasks, because obviously that's, my maths is terrible, but that's like 60 and there's like 160,000 tasks. It's trying to
Mm.
load up in this one kind of UI page. So that's a real pain because we had this like special runbook. That's like, if you want to look at this, make sure you this very specific URL. Otherwise, the web server might just crash because it's too
Okay.
big a thing to look at. So that's something that we had to do. The other thing were the other. I mean, there were more problems when we were on a single instance Airflow cluster, because if somebody took down the web server, they took down the executor as well, which obviously was, that's bad. But that's a kind of architectural problem, which is something else. But that's a bit different. But the other big problem that we had with the UI was that it's it's very hard in the UI to get across the scale and or cost of what you're about to do. So we had these
Mhm.
incidents where people would like they mixed up upstream and downstream. So they cleared a model with upstreams and all its upstreams rather than all the downstreams. And so
Right.
like this is so when you it really that was a very expensive day for many reasons. But when when you have say like 4,000 tasks upstream of yours because you happen to be downstream of a big model that you just want a bit of, for example, that's
Mm.
fine. But it's very, very difficult in the UI to communicate that that's what you're going to do. It says, I'm going to clear all these things, but I don't think that. But it's very hard to communicate sometimes, like either the cost in terms of time or the cost in terms of actual money that you're going to spend doing certain things. And obviously, when you're at a scale of 3 or 4 tasks, it's kind of irrelevant. If you make a mistake, it'll only be a
Mm.
few minutes for that sometimes. But when it in this particular one I'm thinking of, I think that took us like 7 or 8 hours to recover from. And the person who did it was very apologetic, which is it's not really their fault. They made an honest
Yeah.
mistake, but the UI should have had better guardrails to be like, hold on a minute, this seems very odd what you're trying to do. Are you really sure that that's what you want to do? Because
Mm.
that would have been helpful. And so actually on that similar point, first thing they had to do was we had to start restricting access to the Airflow UI for one, but we also started to build in like extra approval levels, basically. So somebody else had to approve what you were trying to do. And we built that into a system that Monzo already had, which is
Okay.
called BizOps. And that has a very kind of extensible interface for like, if you approve things, then you can make certain API calls. So it kind of makes sense. But it was really frustrating for a lot of the data analysts coming in when they were like, "Oh, I've used Airflow at all these other companies. Like, how do I get access to the UI?" And we were like, "Oh, sorry, you can't because it's too dangerous." And like that's
Mm.
and even with reduced permissions models being what they are, kind of makes sense. But it was almost that they weren't granular enough for what we wanted to do, because you almost wanted it to be kind of within, like almost within DAGs rather than just like the kind of whole DAG level and all that
Oh,
kind of stuff.
interesting.
yeah, there were some problems around just like the amount of data the UI is trying to show you, and also because of the fundamental issue that the human's ability to visually reason about more than about 50 things is for the birds, basically. Like, you're not, if you have more than about 100 things on a screen, it's very, very difficult to reason about any of it. So you instantly start trying to cut it
Yes.
down. And actually, to be fair, in the newer versions of Airflow, that was made a lot easier. But then when you're at the level of our team where we were saying like, how is the whole thing running? That's very, very difficult to get to. So that was where, as I was saying before, we had to start moving into the world of like, what do these visual indications and kind of human intuitions mean in metric terms? And that
Okay.
was kind of the big leap we had to make. But yeah, so we had so yeah, so a lot of the problems we had with the Airflow UI were basically just around the idea that it's not very useful at such large scale, and also it just was potentially quite dangerous for a lot of things that you could do with it. So those are
No,
kind
but
of the bigger issues.
that is super. I mean, this is super interesting because that's actually the first time that I hear that, and I mean, with practical examples. And like, do you have an example of what kind of permissions within a DAG you are thinking, like, because you said that sometimes it's not granular enough. So
Mm.
what kind of
I mean, I
like
think sorry.
limiting the number of tasks that you want to clear, for example, for a specific DAG.
Yeah, or even like some level of like approval. Like if you want to clear more than say like 50
Okay.
tasks or something, then it's like, hold on, you need X person to ping you for approval. I mean, because lots of products have those kind of mechanisms built in nowadays. I mean, things like Harness, you can do that with Slack integrations, Jira integrations, whatever you want. It doesn't have to be particularly heavy-handed, but just something that says, because it's all that thing about when you start restricting access to stuff, people often the criticism you'll get is, "Oh, do you not trust us?" And I
Yeah.
think there is, and I think that's a very valid criticism to make. I think it's perfectly valid, but it's always the kind of trust and verify thing, isn't it? It's like, we do trust you, yes, but if you're going to do this, we really want to make sure you've got a good rationale for what you're doing, because that would have prevented so many issues previously. And I think that's the kind of view that we came to. But I think it's more the kind of all or nothing nature of the Airflow permissions you have. It's like you either have all the permissions to do everything you need, or you don't. And there's no way of saying kind of like, we do want to give you these permissions, but we'd also just quite like to verify that they're actually okay. Obviously, for some people, it'll be fine to admin. That's totally reasonable. But for other people, it's like, we just want to make sure that what you're doing is actually what you think you're doing, because sometimes that's not immediately apparent
Yeah.
from commands you can make. It's like,
Yeah. No, that makes a lot of sense. And so you mentioned that you had to monitor some metrics, right? Um.
yeah, yeah. So we started to think. So essentially, a lot of this came from the fact that we were struggling. People would come to us and say things like, "Oh, like how healthy is airflow?" And we were kind of
Yeah.
like, "I mean, it's running." That was that was about as good as it got. And so we really started to think about like, okay, well, what does it mean for airflow to be in a good state? Like, how would we know? And how would we know that without having to kind of go through this sort of folkloric kind of, sort of, staring at the DAG, putting your finger in the air and kind of be like, well, it's about this. How can we get away from that? And so we started to think about defining metrics, and then therefore you could define kind of monitors on the back of it. And so for us, like throughput was the really key one for us. Like how many tasks are
Mhm.
completing, and and what's that been like over the last kind of while? Because the thing that we found was quite hard was that often a lot of the underlying details of Airflow, or at least for us, were, resided in other systems. So, things like the Kubernetes cluster had its own set of metrics. BigQuery itself was a whole
Mm.
load of metrics you can come to. So there was a lot of kind of incidental things, but the big question we were asking was, well, what rate are tasks completing, and has that hit zero? Is that a real problem? Because if the DAG is still processing, that's kind of the starting point. And then kind of further refinements on that, you start to look into things like utilization, particularly of the underlying compute resources. So for us, that was like reservations in BigQuery was a kind of a big deal. Less so on the Kubernetes end of things for us specifically, but I can imagine in other cases that might be true. How well are you utilizing all of the things? How are you utilizing other things you have? And between those two metrics was a pretty good starting point for what we were looking for. But I think or at least the interesting thing was it was very hard to find a lot of guidance on that kind of thing. I would have been
Yeah.
really interested to see like Airflow, the Airflow community coming up with, this is what we think a golden path looks like for decent metrics. Obviously, that's going to vary depending on a lot of specifics around Airflow.
Mm.
But I think it would be really interesting to see what the community would think in terms of, these are the metrics you really want to make sure that you're at least having thoughts about when you're thinking about monitoring. And then you can kind of layer your own platform specific and all that other stuff on top of it. Because I think that's because we had to kind of, as I say, and to be fair, this is something that was kind of starting up as I was leaving. So it's probably, again, it's probably advanced a lot now, but it was quite difficult to start from not very much, because coming from, I mean, I'm a kind of platform engineering background. So with things like Kubernetes, there are an awful lot of very opinionated views about like, these are the key metrics that you should care about. And that's really useful. So it'll be really interesting to see what that would be like in an Airflow
Mm.
context. I'd be interested to see what the discussion about that would be like.
No, that's a super. I mean, this is a very good point. Because like I feel. I mean, obviously, like when you begin with Airflow, you tend to think about how I'm gonna build a DAG,
Mm,
how I'm gonna write a task and so on. You don't think that much about monitoring,
mm,
right? I mean, even if it is a crucial part of your work, you don't really think about that at first. But then you realize how important it is, and then this is when you realize that you don't have, to your point, that much guidelines on
mm,
what metrics you should take a look at, even like what system you should set up to
mm.
monitor Airflow. I mean, obviously you have some rules that you can find on the Airflow documentation, but to your point, it could be better, and I think this is a very valid point.
Mm.
So
Because I think, yeah, because I think also it's a thing of, I think it's something to do with kind of audience initially, because a
yeah,
lot of the time with Airflow, you find these kind of organic installations have grown up over the course of time. So it starts off as kind of one person wants to schedule a few
yes,
models, and then it becomes successful, then it grows out, and then suddenly it becomes then owned by the platform, by say a platform team. And suddenly you then end up with these very different uh, expectations and very different needs essentially from what it is. When you're first setting it up, you just want to get it set up and you just want to run your data, and you're not really that interested. But when it becomes a, as you say, critical piece of infrastructure, you actually care about, is it running well and all that kind of stuff. So
yeah,
I think it's very much a case of, as the audience moves, the expectations move with it. But it'll be, and therefore, we'll be interested to see almost maybe like differentiated documentation about like, if you're running at scale, this is a different thing. So I think there's definitely something to be said for the audience changing and therefore the expectations changing as well. And I think that some of Airflow's history probably is some of the reason why that's the case, because it's, because even talking to other people who've run it, you see it running in everything from teams of 3 people to teams of
yeah.
3,000 people. And those are very different things. But,
Mm.
and suppose it's to Airflow's credit that it can run at those multiple different scales, but it just brings with different expectations around what you're going to need to do if you want to run it for multiple scales.
Yeah, absolutely, absolutely, and also like for the audience, you will find some Airflow best practices. Like if you run Airflow in production in the
Mm,
documentation, so there are still like a lot of information that you will find useful. But yeah, I mean, to your point, it's again like very valid. Your expectations are not the same when you are a team of three than when you are
mm,
a team of thousands. I mean, at least like hundred of people. So you definitely
mm,
have to know what you should look at. I really enjoyed that conversation, but I still have a last one question for you,
mm,
Jonathan. So looking back at your experience running, Airflow with like thousands of tasks, I guess like what advice would you give to teams
mm.
who are starting to eat some scaling issues, with their Airflow deployments? What would you what like based on your experience? What are your recommendations?
Mhm. Yeah, so I think kind of, to kind of cap the end of our previous conversation. So metrics are really, really important. Make sure that you set them up, go with what you think, track them for a while, and then when you start to have incidents, start to look at the metrics and start to work backwards and think, okay, well, what metric would I have needed in order to not have had this incident in the first place? And so it's definitely a kind of build up that operational excellence process and use the metrics to drive that. It's a really kind of important thing, I think. The other point is, I think it's really being clear about kind of where and why you hit scaling issues fundamentally. Like which specific component is it that's causing the issue? Because it's very easy to just say, oh, we're having problems with scaling or whatever. But be really specific about which part of the installation is the problem. And then start to think, how can we target stuff at this? And maybe it's the case that that there's there's another tool that you need. Maybe it's more metrics. Maybe it's maybe it's practices you need to adopt around, the kind of things that I was talking about with approvals and all that kind of stuff. It's very much about, being specific about where the scaling issue is, because very often it will be in a single component or, maybe one or two, because, most things will generally tend to scale in a kind of reasonable way. I think the other thing is, don't necessarily be afraid to build tools outside of Airflow if you need to. Like it's kind, obviously, I'm very much supporter of open source. Definitely go and contribute to the upstream because it's a great experience if nothing else. But don't be afraid to use the best tool for the job. Fundamentally, like if the best tool for the job that's going to get you there quickest is, building something external that can solve your problem, then that's fine. But if it also is going to contribute to the upstream and that kind of thing, then also go do that, because I think, they're both important points. But I think the final thing I would make the point is that when you do hit scaling issues like this, is that sometimes it's time to look at what you're doing and think, why is this getting as big as it is? Because I think fundamentally, I think there are some times where, I mean, we had this a couple of times at Monzo where people would come along and say, oh, well, what if we changed orchestrator? What if we use DAGs, or what if we use something else? And I would constantly say, maybe, but let's focus on the fact that this DAG is really, really big. How could we make it smaller? Because then I think, because otherwise you end up in the kind of, I don't know, the kind of sugar rush of going to a new tool that's shiny and going to fix everything, rather than focusing on the actual fundamental problem, which is that some things are just too big. And so, if you have a choice between new tools and root causes and breaking things apart and all that kind of thing, make sure the main thing is the main thing and split up the things that are big. Because oftentimes with scaling, you know what the problem is. Fundamentally. You don't necessarily know what the solution is, but you at least know what the problem is. And so I think making sure that when you do hit scaling issues, make sure that you're focusing on the right thing and you're not trying to find some silver bullet somewhere, but you're actually focusing on how could I split this down and make it more composable and all that kind of stuff. I don't think you'll go far wrong in that sense.
Wow, I love that. Actually, to your last point, I think it's just like human nature. We tend to. It's very easy for us to add new things. It's very hard to remove things that we've done. It's like we grow up. We don't. We
Yeah.
don't go back small. So I guess like it's just like natural to do things like that. But to your point, having a new like trying to find a new tool, which is very natural again for engineers. Like we like new things, but adding a new tool, adding new stuff, basically, sometimes it's not the solution at all. I mean,
Yeah.
sometimes it's gonna add more complexity, and it's not gonna fix the root cause of your issue. So I mean, I love what you said. I mean, you really should focus on like try to find the root cause and don't try to add new things
Mhm.
and hope that it's going to be better, because
Yeah. And I think,
it's not going to be it's going to
yeah. And I think sometimes there can be a problem where it's about almost kind of what can be palatable to your leadership in particular, because I think it can be I think personally, it can be a lot easier to go to them and say, we're going to spend this money on this new tool and it's going to be brilliant and whatever else. And you can show them fancy demos and, all this kind of thing. I think the much harder sell and the much harder skill is to go in and say, hey, actually, if we spent the 6 months we were going to spend evaluating this on actually breaking this thing down, then we would have this many fewer incidents. I don't feel like that is necessarily as compelling, because ultimately a lot of technical leadership, well, we're also engineers too. But I feel like we really as an industry need to get better at selling the second version of that, because that's ultimately how we get scalable, sustainable software, which is what we all want. But but I think sometimes we're not necessarily the best sales people for that kind of thing. And I think that's really important.
Well, I think we're gonna end on this on that, because it's perfect. It's a really nice way to summarize everything. Right. I mean, thank you so much for joining, Jonathan. It was a pleasure. I guess one last question to you: what is the best way to to stay in touch with you?
Cool. Yeah. So I'm on X at Jonathan P. Rayner. It's Rainer. And you can find me there. I'm also on Blue Sky. I've just started there as well. So you can find me Jonathan
Me too.
Rayner on Blue Sky. And also, if you want to email me, you can email me Jonathan at jonathan-rayner.com. All three of those ways, you can get in touch with me. I tend to I don't necessarily talk exclusively about tech on most of those platforms. I also talk about, my other interests, including baking and drumming and various other things. So, it's a whole smorgasbord of fun things you can come along to enjoy. But I'm always open to conversation, and I love chatting with people. So if you just feel free to just open up either a DM thread or whatever on any of those platforms, and I'll be happy to have a chat.
Wow. Thank you so much, Jonathan. Again, looking forward to meeting you maybe for another episode, but that was
Hmm,
awesome. I
cool.
really learned a lot, and I'm sure that the audience learned a lot too. So thank you so much. Have a good one.
Thank you. Thank you. It's been great.
Take care.